A central theme in our discussions about proportion revolved around the challenges in translating 3 dimensions into 2. In this lecture, I'd like to look more broadly at how we create flatness, volume, and space. The surface we draw on, generally a piece of paper, is flat. In addition to controlling proportions, we often want to create the illusion of 3-dimensional space on that flat surface. Broadly speaking, we could differentiate between 2 types of dimensionality: the volume of an object and the dimensionality of the environment the object occupies, what we refer to as space. Putting these 2 pieces together, we get volumetric form in space. As we've noted, learning to draw is related to learning to understand what we're seeing. There are a number of factors governing the way we perceive depth of space in the world around us. These same factors correlate with the ways we depict space on the page. There are 12 primary factors we'll discuss: overlap, diminishing skies, position along the page's vertical axis, position relative to the format's edges, diagonals creating spatial depth, foreshortened shapes, cross contour, value, light and shadow, value in atmospheric perspective, level of detail, color in atmospheric perspective, and subject matter of recognizable size. The first, and among the most powerful factors governing our experience of depth, is overlap. We know one person is in front of another because they partially cover the second person, concealing part of that person from view. Nothing subtle about it at all. Not surprisingly, it was one of the very first factors artists recognized and used in their drawings. We even find it in cave paintings going back tens of thousands of years. In this example, dating from about 31,000 years ago, it's known as the Panel of the Horses from the Chauvet Cave in France. We see 4 horses' heads overlapping like dominoes. Now, whether this was intended as overlap with the goal of created space is another question. This could have resulted from a single individual drawing all 4 heads, just as we see them today. Or it could have resulted from one person drawing a single head, and then later someone else or several other people coming along adding others, just like the way much contemporary graffiti accrues. So here we can't say for sure. Our Egyptian stele, which goes back to 3,000 years ago, is clearer in this regard. It's pretty flat, but we get a hint of 3 dimensions where Ra's crook and flail overlap his chest and shoulders. We get a bit more where his foot overlaps the object behind it, and we get our most developed sense of space where the kneeling harpist's arm overlaps the harp and strings, which then, in turn, overlap his other arm. In the early 12th century, court ladies' hand scroll, overlap is one of the primary tools used to create a sense of space. The girl in white overlaps the stretched silk, which, in turn, overlaps the woman in the orange robe. And on the right side of the scroll, the woman in white, green, and orange overlaps the box-like structure and the woman in blue and red. And the box-like structure then overlaps the woman in pink and white. In Two Lovers, there are many complex overlaps. The serpentine hose of the water pipe makes its way from the foreground into the midground, overlapping the platform. Then it twists back on itself so that the mouthpiece overlaps the flexible hose. The pillows overlap the young woman. Her hand, in turn, overlaps the man's right arm. His arm overlaps his leg, which, along with the woman's hand, overlaps the back edge of the platform. And in the Sheila, the very structure of the drawing depends on overlap. The woman is closest to us. She overlaps her own reflection, which overlaps Sheila's. This creates a cascading depth of space. In Norman Lundine's White Doe at Home, the recession of space is dramatic. The woman's lower leg overlaps her thigh. The thigh overlaps her arm, which partially overlaps her rib cage and chest. The chest overlaps a collarbone to the point of obscuring it, as well as partially overlapping the neck. The head overlaps the pillow overlaps the bed overlaps the change of plane between the floor and wall. That's a lot of overlap, and not coincidentally, a lot of space. What we've seen in these 6 images spanning 31,000 years is an evolution of the use of overlap. We started out in prehistory where intention is unclear. We moved to some very modest uses in early historic times. then to a firmer understanding of the power of this tool in the Middle Ages, and finally to a full throttle embrace in more recent times. As I'm sure you've noted, as the overlaps become more pronounced, the space opens up accordingly. Our second factor is relative scale. We look out into the world and see two things that we know are the same size, but one looks smaller than the other, so we know the smaller one's farther away. Similarly, if we see two things in a drawing that we know to be similar in size, but one's drawn smaller than the other, we will, all else being equal, feel that they're in different spatial locations. The bigger one closer, the smaller farther away. And this creates a volume of space between the two. This seems natural to us, but it may be learned. The anthropologist Colin Turnbull tells an interesting story in his book, The Forest People. It's about the Mbuti Pygmies, forest dwellers, in what's now the Democratic Republic of Congo. He recounts a hike to the top of a mountain with a Mbuti tribesman named Kenge. Living in the forest, Kenge had never experienced a vista that stretched out and away for miles and miles. In the distance, he saw a herd of buffalo, and he asked Turnbull what kind of insects they were. Turnbull explained that they were buffalo, far off in the distance. He records Kenge's reaction. He roared with laughter and told me not to tell such stupid lies. Well, learned or not, we see scale at play in many drawings from diverse cultures. This is a section of Yuan Dynasty circa early 14th century hand scroll. It's by Zhao Mengfu, and it's titled Twin Pines Level Distance. Look at the scale relationship between the large trees on the right and the much smaller ones in the center, as well as the scale relationship between the central hills and those to the left. We see something similar in the Holbein, but here with figures. Look over the shoulder of the man standing on the far right. The figures behind him are not only overlapped, but in relation to him, they're diminutive, signaling our senses that they're well behind him. Holbein's using multiple spatial signals to compound the illusion of depth. Here, overlap and scale work together, and we'll see this repeatedly. In the Aikens watercolor, we see Biglin and his skull relative to the 9 tiny figures in the skull in the mid-left section of the page. That creates space. Van Gogh uses the same principle in his 1888 drawing of La Croix, though in a different way. The large divisions in the landscape diminish in scale as we move from the bottom of the page to the top. Linear perspective, which we'll discuss in detail later, provides a method for precisely determining how much a set of equal measures should diminish as they recede in space. And this is just what we see in Aiken's preparatory drawing for the Biglin watercolor. The ever-shrinking parallelograms represent the same amount of surface, but in different locations. And this system will tell us exactly how the horizontal widths should diminish. The distance represented by the lower line has to shrink to the size of the line above to represent an equal distance at that depth. In Sheila's drawing, as in the Holbein, overlap is accompanied by diminished scale. The woman is not only overlapping her reflection, but her reflection is much smaller, compounding the sensation of spatial recession. Now, if we don't recognize the subject as being more or less equal in size, we won't feel spatial depth. For example, compare the small figure in the pink robe in the Court Ladies to the much larger figure to the right. We don't read significant depth here because, among other reasons, we know the small figure is a child. She's small by nature, not by optical effect. It's also worth taking a look at how scale plays out in the 4 horses from the Chauvet cave. The horses' heads actually get bigger as they overlap, creating a rather strange spatial sensation. If we flip them so that the smallest head represents the final overlap, the spatial recession feels more normative. Another factor affecting the sensation of depth of space is position along the vertical axis of the format. We noted this briefly in the lecture on how artists compose. In this drawing by Leonardo, the woods are located high in the page and feel distant. By repositioning the woods lower in the page, we change the sensation of depth. The mass of trees becomes much closer. This imitates our experience in life. If you look down at your feet, well, they're pretty close to you. Keeping your eyes focused downward And as you lift your head, your gaze travels away from your feet into increasingly greater depth. That is, until you reach a wall. And this is just what we see in Two Lovers. As we move up the vertical axis of the page, we move back in space. And with the exception of the two figures in the distant room, it's what we experience in the Holbein. And it's exactly what we see in Lundine's White Doe at Home. In the Court Ladies, though the ground's flat, the principle applies. The higher up along the vertical axis of the page we encounter the base of an object or figure, the farther away from us it reads. Our two landscapes, the Jiao Meng Fu and the Van Gogh, function similarly. You move back in space as you vertically ascend the page. In both drawings, the sky acts like an atmospheric back wall. Here's a variation on the theme. If, on reaching the back wall, you continue to lift your head, you'll eventually reach the ceiling. Then you begin to return back towards yourself, finally reaching a point on the ceiling directly above your feet, right where you started. And we find this spatial permutation in many works where we're looking into an interior, like this drawing by Antonio Lopez Garcia, or like some of the examples I showed of my students' hallway drawings. It's also the case in certain landscapes. Here, instead of the ceiling, the sky returns from the horizon and hovers over the land below, like in this Rembrandt drawing, or this watercolor by Winslow Homer. Even in the Aikens, once you reach the sky at the horizon, as you continue to travel vertically up the page, the sky returns forward toward Biglin and the picture plane. Just as we have a foreground, a midground, and a background, we can have a foresky, a midsky, and a backsky. The next factor has to do with our subject's relationship to the format's edges. In this drawing by Norman Lundin, both the figure and the blackboard are cropped. Both intersect the edges of the format shape, with the result that they feel very close to us in space. Biglin is much farther away from us than the model in the Lundin. His skull is just gently cropped on the left. In contrast, Homer's sailboat is much farther away in space. It's located well within the page with space around on all sides. To bring the point home, we can easily push objects or figures back in space. We don't have to do anything to the way they've been drawn. We simply create more distance between them and the edges of the format shape. We zoom out. And inversely, we could bring Sir Thomas More forward in space by closing the distance between him and the format's edges. Just zoom in and crop. In regard to space, there are two types of diagonals. Those that define the edge of an object or part of an object that's parallel to the picture plane, and those that create the illusion of a recession in space. The Egyptian stele has a number of diagonals. There's the angle of the harp, and both the harpist's arms and thigh have diagonals, but they're all parallel to the picture plane, nothing tipping back in space. It took human beings a very long time, most of that 80,000 years that our species has been drawing, for some keen soul to realize that a diagonal could also create the illusion of depth on a two-dimensional surface. That must have been a great day. That guy must have been drawing diagonals for everybody, showing off his new trick. The earliest really convincing examples I know of come from Pompeii and date back about 2,000 years. We could draw the front face of the table, its width and height, using two more or less horizontal and vertical lines. Nothing new here. This could be Egyptian. But once we draw its depth with diagonals, and then add the rear horizontals and verticals, we get a palpable illusion. Being able to do this amounted to a major advance in drawing's history. And we see it put to work in the Song Dynasty court ladies preparing silk. From left to right, we note the diagonals of the long white piece of silk. Then the diagonals of the stool the central woman sitting on. Then in the green mat on the floor. And finally, the diagonals of the box between the women on the right. We find the same thing in our two lovers. The small table among the still life objects in the foreground and the side plane of the dais are constructed much the same way as the Pompeian table. And Holbein is using a similar convention to draw the footstool we looked at earlier. Though here, the diagonals are no longer parallel, they converge toward a point beyond it. and this, as we'll soon learn, is at the heart of linear perspective. The window and ornate doorway on the right are constructed using diagonals that converge toward a point too. Akins uses multiple converging diagonals to help him understand the receding planar surface of the river. And the diagonals need not be linear or obvious. In the Rembrandt, they're soft and gestural. Yet these implied diagonals serve to create the illusion of depth in the landscape. Though the feel of the Rembrandt's different than the feel of the López Garcia, the use of diagonals to construct a depth of space is remarkably similar. Removing diagonals can reveal how important they are. Here's one of my students' drawings of our library staircase. Very good sensation of depth of space, dramatic even. Here's what happens if we crop to a section of the staircase with no diagonals. Pretty flat, huh? As we've noted, not all shapes read as strictly flat, especially those that contain diagonals, because diagonals can pitch us back into space. We've referred to these kinds of shapes as foreshortened shapes. A triangle, well, can simply be a triangle, flat as the piece of paper it's drawn on. Or that same triangle could read as the top plane of a prism receding in space, or a road receding miles back to the horizon. Trapezoids, essentially truncated triangles, function the same way. There's one representing the small tabletop in the foreground in our Punjab Hills drawing, though this one expands in scale as it recedes in space. And the López Garcia is constructed of 4 large trapezoids defining the walls, floor, and ceiling of the room, a very common compositional device. Parallelograms can function similarly. In Court Ladies, both the white piece of silk and green carpet pivot back in space. And there are a number of shapes in the Van Gogh which are related to trapezoids and parallelograms. Triangles, trapezoids, and parallelograms are all angular. The ellipse is a curvilinear shape that acts similarly. In Court Ladies, the fire pit's elliptical. In Zhao Mengfu's Twin Pines Level Distance, the rocks in the foreground and the receding hills are all constructed using foreshortened shapes to create a planar structure suggesting volumetric form. And in the Two Lovers, there are multiple ellipses indicating the object's spatial orientation. As we discussed at length in an earlier lecture, cross-contour can be instrumental in creating a sense of three-dimensionality, turning shape into volume. We also noted how artists in a single line section move from contour to cross-contour and vice versa. The cross-contour describes the 3D character of the form. And as we see in the official's robe, these kinds of lines can be organized to overlap one another. Another example of compounded spatial signals. We'll speak at length about value later in the course. For the purposes of this discussion, it's important to mention several ways values affect our understanding of space and volume. First, the shift from light to dark describes three-dimensional form. One of the ways we know an object has volume is because of the way light plays on its surface. If there's no light, if it's pitch black, we don't see anything. There's no 3D form. With a little light, we begin to see a modest amount of form, but a strong directional light gives the best evidence of volumetric structure. The planes of an object turned toward the light will appear lighter, those turned away, darker. The shift from light to dark is evidence of the underlying planar shift. The planar shift means volume. This is referred to as chiaroscuro. It's Italian. Chiaro, from the same Latin root as our word clear, means light. Oscuro means dark, like our word obscure. So we can use varying degrees of light and dark, or chiaroscuro, to simulate the passage of light over form and create volume. In drawing, we speak about 2 kinds of shadow, object shadow and cast shadow. Object shadow, as the name implies, refers to the shadow on the part of an object that's turned away from the light. We've just seen how object shadow reveals form, but cast shadows can reveal form too. They describe the planar structure of the surface they fall on. Here in Norman Lundine's drawing, the object shadow on the left side of the arms, the breast, and the ribcage and abdomen create the sensation of volume across the figure's horizontal axis. The vertical passage of the object shadow acts like a cross contour to reveal the volumetric shifts along that axis. The cast shadows similarly inform our sensation of volume. The shadow of the left arm falling over the pelvis and abdomen revealed their undulating form, and the large shadow of the wall and windows revealed the contrasting flatness of the blackboard. Another way that value affects our perception of depth is through what we term atmospheric or aerial perspective. It's what we experience when we see a distant mountain or building. The distant object looks less clear than when we're close up. The darks get lighter and many of the bright lights dimmer. It appears to fade into the atmosphere. Another way of saying this is that the value contrasts diminish, and this is accompanied by changes in the way edges appear. Up close, they're clear and precise, but from a distance, fuzzier. It's one of the major guiding principles in the spatial recession in this 13th century ink painting by Chagoué. The landscape elements in the lower horizontal half have the highest contrast and darkest values. This diminishes in the upper right quadrant, and the most distant craggy peaks in the upper left appear as a whisper. Monet applies the same principle in his view of Rouen. We have the highest contrast in the boat and its reflection in the left foreground. Our next highest contrasts are in the midground. Right and left, we have a building, trees, and reflections. Moving back to the central buildings, that would be Rouen, the contrasts diminish. Receding to the hills and clouds behind them, the contrasts fade further. The final strip of gray clouds close to the top of the image gains in contrast relative to the lower clouds. Why? Because these are moving forward in space relative to those close to the horizon. The basic principle could be summed up like this. Greater contrast and clearer edges equals forward in space. Less contrast and less well-defined edges equals farther away. The use of atmospheric perspective not only gives us space, but can also create the illusion of airiness or atmosphere on the page. In this portrait, Ingres is using the same principle and applying it to line. He modulates the architectural events behind the figure so they fade back into an atmospheric depth. The lines get progressively lighter and thinner. He accompanies this with a compositional use of value, striking his highest value contrast in and around the head and next around the hand grasping the elaborate hat. As we noted in an earlier lecture, Picasso, a great admirer of Ingres, uses a similar principle in his portrait of Apollinaire. He's also combining a compositional use of value to create focal areas in the head and forward hand. He uses diminishing line weights and discontinuous line in the far hand, shelf, and the objects and wall to push these into greater depth and deprive them of focus. Artists will even use the same idea in a single head to make us feel that the eyes, nose, and front plane of the head are closer and the ears and hair toward the rear of the skull are farther away. While this isn't applied uniformly in this portrait by Anne Gale, I think you'll see what I mean. Do you see how the top plane of the head fades back into the distance, just like Chagoué's craggy cliffs? This is what Norman Lundin had to say on the subject in an interview I did with him that was published in a catalog on his work. When I compose, I consciously relate the rectilinear aspects of the imagery to the edges of the painting, but I'm interested in breathable air, so I use geometric relationships in combination with atmospheric perspective. Atmospheric perspective can give us that very sense of air. The next principle is related. It concerns the amount of detail we're able to see at any given depth. Clearly, we see more detail close up and less as something recedes from our sight. If someone's close enough, we can read what's on their t-shirt. If they're farther away, we still may be able to tell there's something on the t-shirt, but we may not be able to tell whether it's text or an image. Farther away yet, and we won't be able to tell if there's anything on the t-shirt. And at a yet farther remove, we wouldn't be able to tell what the person was wearing. The principles on display in Zhao Mengfu's landscape. The events in the foreground have the greatest detail, less in the midground, and least in the hills in the distance. In the Holbein, the figure in the foreground is highly detailed. Two figures in the background, considerably less so. And if we look at the Eakins watercolor, we find the same thing. We can tell just what Bigland's wearing. We see the play of light on his body and understand its planar structure. He's three-dimensional. We can even see his reflection. Compare that with the long skull in the distance. While we can count the number of people in the boat, we can't tell much more than that. They're specks without dimension. Our next factor is color. We'll discuss this in much greater depth later in the course. Here, suffice it to say that distance affects color similarly to the way it affects value. We think of color as having three attributes. The first is hue. That refers to the color's blueness, yellowness, or redness. The second's saturation or intensity, referring to the color's level of purity versus neutrality. The last is the color's value, and this refers to its lightness or darkness. Look at the water in the foreground of the Aikens and note the saturations. Now, compare with the saturation of the water in the areas behind Bigland's skull extending to the horizon. The difference is marked. Much more saturated in the front, much more neutral as we recede. Unsurprisingly, this is accompanied by a shift in value contrast as well. More contrast in the foreground, less as we recede. If we compare Bigland and his skull with the figures in Skull in the Distance, we find the exact same thing. And in the sky, we get the color version of what we saw in the Monet. At the horizon, the sky is at its most neutral. As we move higher in the page, Aikens creates the illusion that the sky is moving forward toward the picture plane by increasing the saturation of the blue. We could sum this up as follows: more saturated closer, less saturated farther away. A second effect regards the type of color concerned. One way in which we categorize color is either warm or cool. Warm colors are those associated with fire, yellow, orange, and red. The cool colors are those associated with nature, water, sky, and the like, green, blue, and violet, like most of the palette in the Homer watercolor. The principle here goes like this. All being equal, warm will tend to advance and cool recede. But there's a caveat here. Greater saturation will generally trump the effect of warm advancing and cool receding. In other words, a saturated blue bowl, a saturated cool, will easily advance against a warm that's neutral enough, say a neutral orange or beige wall and table. And high value contrast can often override high saturation too. It's important to remember, these aren't rules, they're principles. Our final consideration has to do with subject matter. Here's a black circle on a page. We can imagine it located on the surface of the page, and we can equally imagine it in the depth of space of the page. Swap a planet of the same size for the circle, and the space becomes palpable. Miles and miles, could be hundreds of thousands, like from the Earth to the Moon. Swap a marble for the planet. While it's still floating in the interior space of the page, we could grab it. It's at arm's length. Finally, swap the model for a penny, and most people will read the penny as sitting on the surface of the page. Let's return to the Homer. Note the figures in the boat. Without the figures, we'd feel space, no doubt. There are many factors working to foster that illusion. But absent the figures, well, the boat could be a 20-footer or a 120-footer. So the space is less measurable without something that has a more or less recognizable measure. Let's recap our 12 factors. They include overlap, diminishing size, position along the page's vertical axis, position relative to the format's edges, diagonals creating spatial depth, foreshortened shapes, cross contour, value, light, and shadow, value and atmospheric perspective, level of detail, color and atmospheric perspective, and finally, subject matter of recognizable size. Using what you've now learned about proportion and space, you're ready to take on some pretty complex drawing problems.